In this video, we'll be talking about the limiting value of a function. And we'll firstly talk about the properties of limits and the theorems on limits. Assuming that limit of x tends to x naught, f of x, and limit of x tends to x naught, g of x, both of them exist. What are we going to have then in terms of limits? We have different theorems for limits, and I'll be taking them. The first theorem is that if limit of x tends to x naught of k, if you have limit of x tends to x naught of k, the answer equals to k. You understand? That is, this k can be any constant number, any real number. 1 can be 2, can be 3, can be 6 into infinity. Like it can ranges from minus infinity to plus infinity. It can be any number that is a real number. You understand? So if you look for a limit of any real number, then you are going to have a real number. The second property is if you have limits of x tends to x naught of f of x plus g of x is going to give you limit of x tends to x naught of f of x plus limit of x tends to x naught of g of x. So this one is x naught, not 0. So let us just say that plus or minus. Let's just say that plus or minus because it applies for both plus and minus. You understand? So what he's trying to say is that this limit is for both f of x and g of x. Is a property of the both of them. You understand? So another one is if you say that limit of x tends to x naught f of x multiplied by g of x, that is equals to limit of x, sorry, this one is supposed to be x naught, not 0, x naught, limit of x tends to x naught f of x multiplied by limit of x tends to x naught g of x. And another one says that if limit of x tends to x naught f of x divided by g of x, it is equals to limit of x, sorry, that is limit of x tends to x naught f of x divided by limit of x tends to x naught g of x. So these are the formulas that we're having. You understand? Given that g of x must not be equals to 0, g of x must not be equals to 0. And this is very, very important because we must not get an undefined answer, just like we have in when we are determining the domain of a function. You understand? Like the videos that we have done previously. So there are some questions that we're going to be solving but before we solve the question, let us talk about some special limits that we have. Some special limits that we have the first one we'll be talking about is limit of x tends to 0 sine x upon x, it is equals to 1. It is always equals to 1. Limit of x tends to 0 sine x upon x, or limit of x tends to 0 sine theta upon theta, it is always equals to 1. And limit of x tends to 0, 1 minus cos x divided by x, it is equals to 0. You understand? Limit of x tends to infinity, then we have 1 plus 1 over x raised to power x. It is equals to exponential. And limit of x tends to 0 of exponential x minus 1 divided by x, it is equals to 1. And limit of x tends to 1 of x minus 1 divided by ln x, it is equals to 1. So these are special limits that we have. These are constants, you understand? These are special limits. Now the question is, how do we apply the formula for limit? You understand? How do we apply the limit theorem. Let us take our first example here. Let us take our first example to be limit of x tends to 2. Limit of x tends to 2. Then we have 3x squared minus 5x, everything divided by x plus 6. So what we are trying to say here is that wherever we see x, just put 2. That is how to go about limits. Very simply, you understand? Very simple. Anywhere you see x, just input 2. That is what they are trying to say. So where this theorem applies is that this x, it is anywhere you see x. Either you see it here, you see it here, you see it here. You understand? Now we are going to be using different theorems. The first theorem we are going to be using is addition and subtraction theorem. That says that if we see x here and we see x here, we are going to put these 2 for the both x. And the second one is the constant theorem that says that limit of any constant equals to that constant. You understand? So how are we going to go about this? It is not going to be equals to what? It is not going to be equals to 3 into bracket 2 raised to power 2 minus 5 into bracket 2, everything divided by 2, which is our x, plus 6. Why is it 6? The reason is because the limit of any constant number equals to that constant number. You understand? So we see x here, we replace it with 2. We see x here, we replace it with 2. We see x here, we replace it with 2. You understand? So that is how it works. So let us calculate now. So this one is going to give us 3 multiplied by 4, that is equals to 12, minus 5 multiplied by 2 equals to 10, everything divided by 2 plus 6. And that will be equals to 10 minus 2, 10, 10 minus 12, or 12 minus 10 rather. That will be equals to 2 upon 8. And that's going to give us 1 over 4, which means limit of x tends to 2 of 3x squared minus 5x divided by x plus 6 is giving us 1 over 4. That's our first question. Now, let us do another question here. Let us say that limit of x tends to 1 of 3x squared plus 1, for example now. So what are we trying to say is that anywhere we see x, we put 1. You understand? So that will be equals to what? That will be equals to root of 3 into bracket 1 squared plus 1. And that's going to give us what? Root of 3 plus 1. And that's equals to root of 4, which is equals to 2. You understand? So remember, always remember that limit of any constant number equals to that constant. You understand? Limit of any constant number equals to that constant number. Now, let us take another example that we have here. Let us say that we have limits. Okay, let me write that in white pen. Limit of x tends to 3, then x minus 3 divided by x squared minus 9. You understand? So what they are trying to say here is that anywhere we see 3, whenever we see x, we are going to put 3. So our answer here will be 3 minus 3 divided by 3 squared minus 9. And that will be equals to 0 divided by 0, right? And if you press your calculator, 0 divided by 0 is undefined, right? It is undefined. Now, remember that we have mentioned that g in our previous theorem that we mentioned that our g of x, which is our denominator, must not be equals to 0. We have mentioned that already. Our g of x, which is our denominator, must not be equals to 0, which means since we calculated this one and we have 0, something is wrong somewhere. We must not have anything divided by 0. You understand? Because we must not get an undefined answer, which means we can look into this particular one. Look at it. We can see that it's a difference of 2 squared. We can make it a difference of 2 squared because x raised to power 2 minus 9 is the same thing as x squared minus 3 squared. And remember, difference of 2 squared, a squared minus b squared equals to a plus b, a minus b, right? Which means we can write this as what? We can write it as x plus 3, x minus 3. Therefore, we can say that our question is now limit of x tends to 3, you understand, x minus 3 divided by x plus 3, x minus 3. So the next thing is that the x minus 3 is going to cancel x minus 3, and we're going to be having limit of x tends to 3 to be 1 upon 6, you understand, or 1 upon x plus 3. And that means what? Anywhere we see x, we are going to put 3, right? That will be 1 upon 3 plus 3. And that's going to give us what? That's going to give us 1 upon 6. So our answer is going to be 1 over 6. So instead of having 0, you understand, instead of having 0 as our denominator, we are going to look for every possible means to avoid 0 as our denominator. You understand? Now, let us take another example here. Let us say that we have limit of x tends to 1, then it is x squared minus 1 divided by x minus 1. You know, if you input 1, we are going to be having 1 minus 1 divided by 1 minus 1, and that's going to give us 0 divided by 0. Sorry, 0 divided by 0, and that is going to give us an undefined answer, right? Remember, I told you we are going to look for a way to prevent an undefined answer, right? So what is the next thing we can do? We can look at this numerator. We can say that 1 squared is the same thing as 1, which means we can write it as x squared minus 1 squared divided by x minus 1, which will give us in difference of 2 squared, that will be x plus 1, x minus 1, everything divided by x minus 1, right? So x minus 1 is going to cancel out x minus 1. We are going to be left with limits of x tends to 1 of x plus 1. And that's going to give us what? 1 plus 1, which means our answer for this particular limit equals to 2. You understand? So that's how it works. That is how it works. You understand? Unless we are given something like this, let us say we are given something like this. In that case, we cannot avoid limit of x tends to 1, x minus 1 divided by x minus 1. Look at this particular question now. You understand? In this question, we have been given something like this. Let us say they put something like this there, which means they are saying that it is an absolute value. There is no how you can prevent something like this. It is still going to give you 1 minus 1 divided by 1 minus 1, and that's equals to 0 divided by 0, which means it is an undefined answer. And this is what will be the answer for this one. Therefore, we can conclude from this one that the limit does not exist. The limit does not exist. You understand? In this case, we can conclude that the limit for this particular one does not exist. You understand? Now, let us take for an example. We have something like this. We have something like limit of x tends to 4. You now say that x minus 4 divided by x squared minus x minus 12. You understand? The same way we used to do it, anywhere you see x, just put 4. You know that's going to give us what? That's going to give us 4 minus 4 divided by 4 squared minus 4 minus 12. And that's going to give us 0 divided by 0, because 4 squared equals to 16, and 16 minus 4 minus 12 equals to 0. You understand? So this one is going to give us undefined answer as well, which means there must be a way we can prevent this undefined answer, and that is by looking at the denominator. The denominator is a quadratic equation, so we have to solve it quadratically. You understand? And the only way we can solve it quadratically is by looking for a number that's a factor of 12, numbers that are factor of 12 whose sum equals to minus 1. You understand? And that is minus 4 and plus 3. You understand? Minus 4 and plus 3, which means in this case we can say our answer is x squared minus 4x plus 3x minus 12, right? And if you factorize the both, we are going to be factorizing x out of this one. We are going to be having x into bracket x minus 4. We are going to be factorizing 3 from this one. That will be plus 3. That is x minus 4. Which means after factorizing this one quadratically, we are going to be having what? We are going to be having x plus 3 and x minus 4, right? Therefore, anywhere we see this particular formula, we are going to replace with x plus 3, x minus 4, which means our limit of x tends to 4 will now be equals to x minus 4 in denominator and x plus 3, x minus 4 in the denominator. So x minus 4 is going to cancel out x minus 4, and we are going to be left with 1 divided by 4 plus 3, and that's going to be 1 divided by 7, and that will be our answer for this particular one. So that is how you will look for a way to avoid something that's going to give you 0 at the denominator. You understand? Let's take another example. Let's say we have something like limit of x tends to 2, x squared plus 2x minus 3. You understand? That's going to give you a normal thing. That's just going to give you what? 2 squared plus 2 multiplied by 2 minus 3. And that's going to be 16 plus 4 minus 3. You understand? So 2 squared equals to 4 rather. 2 squared equals to 4. So that is 4 plus 4 minus 3. And that is equals to what? That is equals to 5. You understand? So that is how to solve limits when you're having limits of a function. So let us give you an example here. Let us say that limit of x tends to 2 of x squared minus 4 divided by x minus 2. So this is a question that you can pause the video and check if you can quickly do it. So we can quickly do this one by turning this one into different of 2 squared. We are going to be having x squared minus 2 squared divided by x minus 2, and that's going to give us what? That's going to give us x squared. Sorry, that's going to give us x minus 2, x plus 2, everything divided by x minus 2. And if we cancel out this one, we are going to be having what? X plus 2 left, which means our answer will be 2 plus 2, and that's equals to 4, which means my answer for this one is equals to 4. You understand? So those are the ways that we can use in solving limits of a function. You understand? And this is where we'll be stopping for today's example. And in the next video, we are going to be solving more example on limits of a function, especially when we are dealing with limits tends to infinity and limits of something like polynomial function. Thank you.